Now, we will describe motion with variable speed, introducing a fundamental concept of acceleration. So, acceleration is one of the fundamental concepts in mechanics in general. Acceleration is defined as the rate of change in velocity or speed, the rate of change in velocity or speed. So consider a car initially moving at 5 meters per second. So a car moving initially at 5 meters per second. The driver then decides to increase the car's velocity, let's say to 20 meters per second. So he applies the accelerator over a period of 5 seconds. So it takes him 5 seconds to increase the speed of the car from 5 to 20. This means that it takes him 5 seconds to increase the velocity of the car by 15 meters. From 5 to 20 means that the velocity increases by 15 meters per second during 5 seconds. The acceleration is the rate, which means that we need the rate of change or the change within 1 second. So 15 meters per second during 5 seconds means that the velocity decreases by 3 meters per second each second. 15 within 5 is equivalent to saying that it increases by 3 each second, by 3 meters per second each second. And this is written as the acceleration, which is designated as A, is equal to 3 meters per second. So the velocity or the speed increases by 3 meters per second or each second, or 3 meters per second square. So meters per second square is the SI unit of the acceleration, which is a very important unit of the acceleration. The change in speed indicates either when we say that the acceleration is the rate of change in speed or velocity, this indicates either an increase or decrease in the speed. So let's say now that the driver or another driver applies the brakes to decrease the speed. For example, if the speed decreases if the driver applies the brakes to decrease the speed from, let's say, 20 meters per second to 10 meters per second, and it takes him, or he applies the brakes for a period of 2 seconds. So again, from 20 to 10, this means that the speed has decreased by 10 meters per second, decreases by 10 meters per second within 2 seconds. Again, we need the change within 1 second. So the acceleration is the change in the speed per 1 second or per second. So 10 divided by 2, it is 5. This is equivalent to 5 meters per second, or the acceleration is now written as A equal 5 meters per second square, and I'm going to put the minus sign here. The minus sign indicates that the car is decreasing, the speed decreases, so the minus means, so if we write A equals minus 5 meters per second square, this means that the car is decelerating or the speed increases. So the minus sign, decreases, The minus sign indicates that the speed decreases by 5 meters per second each second. So this indicates decreasing. This rate of change in velocity or acceleration can be constant, as in the previous examples. For example, here, the speed increases 3 meters per second each second. So each second it increases 3 meters per second. Each second it increases by 3 meters per second. Here it decreases by 5 meters per second each second. Alternatively, it can be variable, such as the car has an acceleration. For example, a driver is driving in a way that he increases the speed 3 meters per second for the first 2 seconds, then he moves with a constant speed for the other 3 seconds, then he moves with another acceleration 4 meters per second square, and then he decreases the speed again, and so on. We are not going to study the motion where the acceleration is varied and every time we have a new acceleration of the object. No, we will focus on a motion with a constant rate of change where the acceleration is constant. So we are going to study the motion where the acceleration is kept constant through all the motion. Such motion, so we're not going to study the motion when the acceleration is variable and each time you have a new acceleration. No. Such a motion where the acceleration is constant is referred to as uniformly varied or accelerated motions. So the type now of motion, so we have discussed in the previous lecture the uniform motion where the speed is constant. In this lecture, we are going to see the uniformly accelerated motion. It is the motion where there is an acceleration, but this acceleration is constant through all the problem. Uniformly accelerated motion, where the acceleration is constant. It might be positive or negative depending on whether the speed is increased or the speed increases or decreases. As also previously mentioned in the previous lecture, the primary objective is to determine the equation of motion. Which describes the displacement or the distance denoted as x as function of time in terms of time. We need to know the distance at each time of the moving object. This is the equation of motion. And from this equation, we can deduce many other factors as the speed and the acceleration. In case of the uniform motion, x equal vt. This was the only equation that we have seen. It is the equation of motion which relates x to time. So this is in the case of uniform motion where the speed was constant. And hence, if the speed was constant, and hence we have defined the acceleration as the change in speed. Here the speed is constant. This means that there's no change in speed, and hence the acceleration is equal to 0. So in uniform motion, the definition of the uniform motion can also is the motion where the acceleration is equal to 0. So here we have, uniformly accelerated motion. Now we are going for acceleration. So this was the sole equation. Governing uniform motion. For uniformly accelerated motion, we are talking about the uniformly accelerated motion. The equation of motion is given by, so this is the equation related to the uniformly accelerated motion. It is given by which is very famous equation, x equals a t squared over 2 plus v initial t. As a reminder, t squared means, so t squared in algebra means t times t. For example, 5 squared is equivalent to 5 times 5, which is 25, and so on. Where a is the acceleration, so x is the distance or displacement. X is the distance or displacement in meters, and the SI unit is meters, as we have mentioned before. A is the acceleration. We are talking about uniformly accelerated motion. Then we have the value of the acceleration, which is constant. So it is the acceleration. And the SI unit, as we have seen, meter per second square. T is the time. T is the time in seconds. The SI unit is seconds or second. V initial. Now, since we are talking about variable speed, then we expect different values of speed since the velocity is being changed, or the velocity increase or decrease. V initial is the speed where initially the car was moving before, or the speed initially the car had before changing or before applying the accelerator to change the speed. So suppose the car was moving with 10 meters per second, then, as we have mentioned in the previous examples, for example here, it was 20 meters per second, then it changed to 10. This means that initially the body was moving with 20, so this is the initial speed. In the example here, the car was initially moving with a speed of 5 meters per second. This means that the initial speed here is 5 meters per second. So this is the initial speed, which again, it is the initial speed at which the car was initially moving before changing the speed. Initial speed, again, meter per second. So this is the time equation, which expresses the distance, or displacement corresponding to each time. From this equation, 3 more equations can be deduced. And we are going to write down these 3 equations. And to solve any problem related to uniformly accelerated motion, we must use one or more of these 4 equations. And the specific equations chosen, or which equation to choose, depends on the given and required variables in the problem. These equations are, which are very important. First, V equals, so let's call this equation 1, which is the equation of motion. The second equation is that V equal AT plus V initial. Again, A is the acceleration, T is the time, V initial is the initial speed, V is the speed. So now, again, the speed changes from V initial. So this means that the speed changed from V initial to V after a time T. So V is the speed, is the new speed, or sometimes we call it the final speed after time T. So this is equation 2. The third equation, we have 4 equations. The third equation is V squared minus V squared initial is equal to 2A, 2 times A times X. So the speed square minus the initial speed squared is equal to times the acceleration times the distance. Again, V is the new speed, V initial is the initial speed, A is the acceleration, and X is the distance or the displacement. This is the third equation. The fourth equation is X equals half or we can write it in the form as, which might be, so it is again V initial plus V times T over 2. This is the fourth equation. So once we have a problem related to the uniformly accelerated motion, we have to use one or more of the four equations, depending on the given and required variables in the problem or the exercise. In the next lecture, we are going to see different applications, problems, and exercises where we can use these equations.